The ship was moving at 6 knots toward the lock entrance. The captain rang slow ahead on the telegraph to reduce speed, but the vessel did not slow down. We kept surging forward. The distance to the concrete lock gates was closing fast. The bridge rang "Stop!" but the propeller kept turning. We were accelerating into the dead end. Down in the engine room, the linkage arm connecting the governor to the fuel pumps had sheared off. The steel pin had snapped from metal fatigue. Without that connection, the strong return springs pulled every fuel rack to the maximum setting. The engine was uncontrolled. It was taking full fuel regardless of the telegraph setting. This happened in 1982 on a bulk carrier entering the locks at Antwerp, Belgium. I was the third engineer. It was a busy morning. We were maneuvering in the River Scheldt. The chief engineer was at the maneuvering console and the second engineer was checking the generators. I was standing near the log desk. The chief realized the RPM was not dropping. He grabbed the emergency stop lever on the console and pulled it back hard. The linkage clattered, but nothing happened. The engine speed actually increased. The tachometer needle climbed past 80 RPM. The heavy pistons were thumping harder and harder. The noise from the turbocharger became a high-pitched whine. It was much louder than normal. The chief shouted at me, pointing toward the side of the engine. "The racks! They are stuck open." The vibration on the deck plates increased. We were putting out maximum power while only meters from the dock. I ran toward the fuel pumps. There were 6 cylinders, all connected by a long steel control rod. I grabbed the rod with both hands. It was extremely hot. I tried to push it back toward the stop position. The springs fought against me. The force was too heavy for one man. Before I tell you what happened next, please consider subscribing. It helps this channel reach more sailors. The second engineer saw me struggling. He dropped his clipboard and ran over to help. We both grabbed the hot control rod. The heat burned through our gloves. Together we pushed with all our weight. Slowly the fuel racks moved back. The engine noise dropped. The RPM began to fall. It seemed impossible to operate a 10,000 horsepower engine with just our hands. But you won't believe how we managed to maneuver the ship using a simple length of pipe and a system of hand signals. I'll get to that in a moment. Suddenly the telegraph rang, full astern. The bridge needed braking power immediately. The chief yelled, "No, let go." We released the rod. The springs instantly snapped the racks back to full fuel. The engine roared again. The chief tried to engage the starting air to reverse the engine, but the interlock prevented it. We were moving too fast to reverse. The engine was turning. Ahead at full power, the chief signaled us to force the racks to zero. Again, we slammed them shut. The engine finally stalled and went silent. But now the ship was drifting silently toward the lock gates with no power to stop. The telegraph rang loudly in the engine room. The pointer swung to full astern. The chief engineer looked at us. "Get to the racks," he shouted. The ship was still carrying headway toward the lock gates. We had to stop the momentum immediately. The second engineer and I positioned ourselves along the engine. He stood near the aft cylinders. I stood near the forward ones. The fuel control rod ran past us at chest height. It was a solid steel shaft, about 3 meters long. It was coated in oil and grease. The chief grabbed the maneuvering lever. He watched us closely. "Ready?" He yelled over the noise of the auxiliary blowers. We nodded. He pushed the lever to the start position. The cylinder heads hissed as 30 bars of compressed air rushed in. The massive engine began to turn. The pistons moved up and down on the air pressure alone. But there was no fire. The RPM stayed low. "Push," the chief signaled. We leaned our weight against the control rod. We had to fight the heavy tension of 6 spring-loaded fuel pumps. We pushed the rod forward. The fuel index pointers on the pumps moved from 0 to 30. The engine made a deep, thumping sound. It caught fire on the fuel. The exhaust temperature gauges started to climb. The engine was running astern. The vibration changed instantly. When running on air, the engine was smooth. Now under power, the control rod shook violently in our hands. It jerked back and forth. The metal was hot, radiating heat from the engine block. I adjusted my grip, trying to find a spot that wasn't burning my gloves. "Hold it steady," the second engineer yelled. He was struggling to keep his footing on the vibrating deck plates. We had to act in perfect unison. If I pushed and he didn't, the rod would bind. If we weren't synchronized, the fuel delivery would be uneven. The chief watched the tachometer. The needle was bouncing around 60 RPM. He signaled with his hand, "Palm down, slow down." We eased the pressure on the rod. The springs instantly pushed back against us. We let the rack slide back to index 20. The engine slowed, but it kept firing. Sudden loud banging came from the hull. The propeller was churning the water, acting as a brake. The whole ship shuddered. We were fighting the forward momentum of 30,000 tons of steel. My arms began to cramp from the tension. The rod felt like a living thing trying to escape our grip. The telegraph rang again. Stop. Then immediately, slow ahead. The bridge was trying to twist the ship in the narrow channel. The chief cut the fuel. We let the rod snap back to zero. The engine stopped. Ahead! Now! The chief barked. He applied the starting air again. We reversed our grip to push the rod the other way. We were the governor now. We were the only thing controlling the speed of the ship. It was a dangerous way to operate. The chief wiped sweat from his eyes. He saw us shaking from the exertion. The engine room was 45 degrees Celsius. The noise was deafening. We were standing right next to the moving parts. If one of us slipped on the oily plates, we could fall into the machinery. If we lost our grip on the rod, the engine could overspeed. A runaway diesel engine can disintegrate in seconds. The flywheel could explode and tear through the hull. The chief had a choice to make. He could order us to stop. He could tell the bridge that the engine was broken and cannot be used. The ship would have to drop anchors and pray that they held in the soft river mud. That would be the safe procedure. Or he could trust two exhausted engineers to manually control a massive machine for the next hour of maneuvering. It risked our safety and the engine itself, but it was the only way to get the ship to the berth under its own power. It was a terrible choice. What would you have done in this situation? The chief decided to press on. He signaled us to keep our positions. For the next 20 minutes, it was a test of endurance. Half ahead. We pushed. Out, stop. We released. Slow, astern. We pushed again. My gloves were soaked with oil and sweat. Finally, the bridge rang, finished with engines. The ship was secured alongside the lock wall. We let the rod slam shut for the last time. The engine went silent. I leaned against the crankcase, breathing heavily. My hands were trembling uncontrollably. Good job, the chief said. He came down from the control platform. But we can't do that again. We need to fix this before we leave the lock. The lock transit would take about 45 minutes. That was our window for repairs. We examined the breakage. The steel pin connecting the governor arm to the control rod had sheared clean off. The remaining piece was stuck inside the clevis. We didn't have a spare pin of that exact size. We can wire it, the second engineer suggested. He found a roll of heavy-duty seizing wire. It was thick, galvanized steel. If we wrap it tight enough, it will hold the linkage together. It wasn't a permanent repair, but it looked strong. We worked fast. The metal was still searing hot. We used pliers to twist the wire. We looped it through the clevis and around the arm 6 times. We twisted the ends until they were tight. The linkage felt solid. I pulled on it. It didn't budge. That will hold, I said. We gathered our tools. We thought the crisis was over. We started to clean up the oil on the deck. Suddenly, the alarm bells went off. The telegraph rang furiously. Emergency full ahead. The ship must have been slipping its lines, or the lockmaster ordered an immediate move. The chief sprinted back to the console. He didn't wait for us to get to the racks. He trusted the wire repair. He threw the lever to start. The air kicked in with a violent jolt. The governor actuator slammed forward, pulling hard on our wire fix. There was a sharp ping sound. The wire snapped instantly under the torque. The heavy steel linkage arm swung loose. But this time it didn't just hang free. The momentum carried it downward. The heavy steel arm jammed between the engine frame and the fuel rack lever. It acted like a wedge. "Fuel!" the chief screamed. The air was turning the engine, but it wasn't firing. I lunged for the control rod. I grabbed it and tried to push. It was rock solid. The loose arm had mechanically locked the entire fuel system at 0. "It's jammed!" I yelled. The second engineer joined me. We both pulled and pushed. It was like trying to move a welded beam. The engine was turning on air, consuming our limited supply, but we couldn't give it a drop of fuel. The starting air pressure dropped below 15 bar. The engine slowed down. The turning stopped. We were drifting in the lock entrance, completely disabled. The current was catching the stern, pushing us toward the concrete pier. We had no engine, and the manual control was physically locked up. The chief pointed at the jammed linkage. "Break it loose," he shouted. The telegraph was still ringing. Emergency full ahead. We had less than 2 minutes before the current pushed us into the concrete pier. I grabbed a heavy ball-peen hammer from the shadow board. The second engineer grabbed a long steel pry bar. We attacked the engine like it was an enemy. I swung the hammer hard. It struck the jammed steel arm with a loud clang. Sparks flew, but the arm didn't move. The wedge was under incredible tension from the fuel springs. "Hit it again," the second yelled. He jammed the tip of the pry bar behind the arm to apply leverage. I adjusted my grip and swung with everything I had. The hammer connected solidly. There was a sharp crack. The jammed arm popped free and fell into the oily bilge. The fuel control rod instantly snapped back to the 0 position. The rack was free. But now we had a new problem. The rod was scorching hot and our hands were blistered. We couldn't grip it tight enough to fight the springs for another hour of maneuvering. We needed leverage. The second engineer ran to the workshop. He returned seconds later carrying a massive 36-inch Stilson pipe wrench. It was heavy, made of cast iron with jagged steel teeth. This was our improvised solution. He slammed the jaws of the wrench onto the round fuel control rod. He tightened the knurled nut until the teeth bit deep into the steel shaft. Now, instead of a slippery, hot rod, we had a 3-foot lever sticking up at a 90-degree angle. "Ready!" I yelled to the chief. I grabbed the handle of the pipe wrench. It gave me tremendous mechanical advantage. I could now fight the force of all 6 fuel pumps with just one arm. The chief looked at the starting air gauge. It read 14 bar. We usually needed 25 bar to start the engine. We had enough air for one attempt. If the engine didn't catch fire immediately, the compressors wouldn't have time to recharge. We would hit the pier. The chief didn't hesitate. He threw the lever to start. The air valves opened with a sickeningly slow hiss. The pressure was low. The massive pistons began to turn. Chug, chug, chug. It was too slow. The compression wasn't building up heat. "Give it fuel," the chief signaled. I pulled back on the pipe wrench handle. The teeth dug into the rod. I forced the fuel racks to the 50% index. The engine groaned. It turned over one more time. Then a cylinder fired. Boom, then another. Boom. Thick black smoke erupted from the turbocharger. The engine shook violently as it fought to overcome the inertia. I held the wrench steady, refusing to let the rack drop back. The RPM shot up. The turbocharger whine began. We had power. The chief swung the telegraph to answer the bridge. The propeller bit into the water. The stern of the ship shuddered as the wash kicked against the rudder. We began to pull away from the concrete wall. We cleared the corner of the lock entrance by less than 5 meters. For the next hour, I stood by that pipe wrench. I became the human governor. When the bridge rang slow, I eased the wrench forward. When they rang full, I pulled it back. The vibrations traveled up the handle and into my shoulder, but the leverage made it manageable. The second engineer monitored the exhaust temperatures, signaling me to adjust the fuel if a cylinder got too hot. We entered the locked chamber smoothly. The bridge crew had no idea that down below their engine was being driven by a pipe wrench and an exhausted engineer. When the lines were finally fast on the bollards, the order "finished with engines" rang out. I pushed the wrench forward one last time. The engine died. The silence that followed was heavy. The chief walked down from the plates. He looked at the pipe wrench still clamped to the control rod. The teeth had chewed deep marks into the steel shaft. "Leave it there," he said quietly. "We might need it for the undocking." We spent the next 8 hours in port rebuilding the governor linkage properly. We machined a new pin on the lathe and reinforced the connecting arm. But we kept that pipe wrench nearby for the rest of the voyage. This incident taught me a valuable lesson about the difference between modern shipping and the old days. Today, engines are controlled by microprocessors and solenoids. If the electronics fail, the ship stops. There is no manual override. You're at the mercy of the tugs. But on those old mechanical engines, you could always find a way. As long as you had air to turn the crank and fuel to burn, you could make it run. It didn't matter if the governor broke or the linkage snapped or the bridge control failed. With a hammer, a wrench, and a bit of sweat, you could get the ship home. That level of mechanical intimacy is gone now. Engineers today are operators, not mechanics. They replace circuit boards. They don't fight return springs with a pipe wrench. It was dangerous work, and it was hard, but it made you respect the machinery in a way that looking at a computer screen never will. I kept the gloves I wore that day. They were stained black with crude oil and burned stiff from the heat of the control rod. They reminded me that when the technology fails, it all comes down to your hands. Have you ever had to bypass a safety system or build a tool from scratch to save your ship? Tell me your story in the comments below. I read every single one. Stay safe out there.